Assalamu alaikum everyone. Today I will be presenting our simulation of an IoT-based smart computer laboratory developed and simulated using Cisco Packet Tracer. The objective of this project is to create a secure, responsive and automated lab environment that enhances safety, energy efficiency and real-time monitoring using interconnected IoT devices. The setup includes a DNS server and a web server that represents a simplified model of the internet, and a LAN Wi-Fi hybrid network that represents the laboratory network, all the PCs and all the IoT devices interconnected together. So let's test the network. So these are the laboratory PCs that will be accessed by the students. They can communicate with each other very easily, like this. They can also communicate across the network. They can also access the web server right here by logging into one of their PCs, opening their web browser. And if we type in www.bupcsc.edu.pd, we will be greeted by the homepage of this web server, and the translation of this URL is done by the DNS server right here. Now let's take a look at our IoT devices. Our lab integrates a webcam, an air conditioner, a temperature monitor, windows, a siren, lights, a door, a furnace, and last but not least, a fire monitoring and detection system that also includes the siren. And all of them are connected to a wireless access point that connects all the devices to the rest of the network. We have also implemented several smart device conditions on the IoT server to automate lab behavior that will be supervised by a system administrator. Let's take a look. So we have to type the IP address of the IoT server, the username, and the password. So here we can see all of the devices that are connected to the access point. We can turn them on or off individually from here. And here you can see the conditions, the device conditions that are required to automate the behaviors of these devices under special conditions. If someone opens the door, the webcam will turn on, the lights will turn on, and the AC will also be activated because there are people present in the room. Now, if the temperature is too cold, then the furnace will be turned on and the AC will be turned off. If it's too hot, then we need the AC to be turned on. If the AC is on, the furnace will be turned off and the windows will be closed because ACs cannot work otherwise. If it's too hot, the AC will automatically activate. And finally, the fire emergency system, the most important part. If any sign of fire is detected, then all the IoT devices will be turned off and the door will be unlocked to make sure everyone can escape swiftly and safely. Now let's take a look at the simulation. So if someone opens the door, the lights are on, the webcam is on, and the AC is also turned on. And as you can see, the temperature is decreasing. So now as you can see, if it's too hot, the AC will be turned on automatically and the temperature will be reducing very quickly. Now let's take a look at the emergency fire alarm system. Let's say there is a fire. As you can see, immediately the fire sprinkler is turned on, covering the room with water, and the door is unlocked, and the siren is activated, and the windows are open to make sure everyone can escape quickly and safely. And when the fire is under control, everything will return to normal very soon. To summarize, this smart lab demonstrates how IoT can be used to build intelligent educational spaces that are autonomous, energy aware, and prepared for emergencies. It also reflects a real-world application of smart infrastructure and responsive systems in institutional environments. So that concludes our presentation. Thank you, everyone.